Hello, everyone. Welcome to today's lesson. And in today's lesson, we are going to continue from where we left off on the topic binomial probability. So today's lesson is going to be lesson 3. In lesson 2, we looked at binomial probability question that involves at least, and at most. At least your success, at most your success, at least your failure, at most your failure. How to deal with that. Okay, and the assignment that was given after the lesson was the first question under sort past questions or likely exams question. Okay, so we are going to continue from there. So what you did, as your assignment in actual fact was a past question. Okay, so I am going to continue, from there. So that's why you see question 2. So at the normal circumstance, this is supposed to be question 1. Okay, so question 2, because we've done the question 1 as a class, also as an assignment. Now we are going to continue from here. So you are going to make use of all the concepts that we've learned so far under the topic binomial probability to handle selected past questions, and likely exams questions. Some of the past questions are direct, some there are variations. Okay, so now quickly let's look at this question that we have here. And today you will be talking a lot because I will be calling you one after the other because I know that I've given you all the information that you need. Okay, so quickly let's look at the first question, which happens to be question 2. A fair coin is tossed 10 times. Find the probability of obtaining A, exactly 9 hairs, B, no tails, C, more than 8 hairs. Okay, so with this one, per the advice that you've been given, which outcome would you, or is it advisable for you to take as what the success? Is it head or tail?
Head.
Head. Okay, why?
Because it appears in most times in a question.
Very good, as simple as that. Okay, and
So,
immediately you know this, it means you basically want to reduce moving from your failure, to your success. Sorry, moving from your success to your failure, forgive me. Okay, so now this is what we know. Solution is what you write first. Okay, after solution, you have a major question number. So question number 2, oops, question number 2. Okay, and you know there's a binomial probability question, which will involve the function. So quote the function. So you know that P capital X is equal to what? X, small x, will be equal to N combination X. Okay, then small p to the power X, small q to the power N minus X. All correct. Okay, we need, the values of the parameters that we have here. Okay, so we need P, we need Q, and we need N. So you come and write but, and the B should be a capital B. We are starting a new sentence. So but your N will be the number of fixed trials. So N is equal to how many? 10. Okay, so 10 times number of trials. Is that clear? Your P, because it's a fair coin, your P will be your probability of success. So this is a capital P, this is a small p. Okay, and we said we are taking our usual head as the success just for the simple reason that it appears most in the question. So head. Okay, and that will be equal to, for every fair coin that you toss, the probability of obtaining a head will always be 1 over 2. Okay, just as the probability of obtaining a tail will be 1 over 2. So this will give me 1 over 2. Then comma, you need your Q. So Q will be equal to 1 minus P, which will be 1 minus half, which will also give us what? Half. Okay. Is my point well made?
yes.
Okay, so like I said, if you like, you can write comma x is equal to the number of successes or ignore. You should have at the back of your mind that the x is your number of successes. So in this case, what do? We can now go to A. And when you are moving from this information that you have here to the A, you don't leave a line. Okay, remember I told you, you leave a line when the answer to this question, am I moving from a sub question to another sub question? If the answer is yes, then you leave a line. Okay, when you are writing the A, you are not moving from a sub question to another sub question. In fact, the first sub question is A. Okay, so there's the first sub question. You don't leave a space. So now you come and write therefore, okay, P, you are looking at probability of what? Exactly 9 hertz. So exactly 9 hertz. Okay, we know your probability here is in terms of your success. So it means you can write it directly in terms of your x. So it will be px, capital S is equal to what? Number of successes we know is what? Is 9. Okay, so it means we are going to get, okay, what combination? 10 combination 9 because our n is 10. So 10 combination 9. Okay, then in bracket 1 over 2 to what power? To the power 9. Do you agree? Then
Yes,
1 over
please.
2 to what power? To the power 1. It will be 10 minus 9. I've told you always when you add the exponent here, you should get your n. Okay, so at this point, we are in a comfortable lead. So this will be equal to 10 combination 9 is what? Is it 10?
10.
Yeah. Okay, so that will give us 10. Then 1 over 2 to the power 9 will give us 1 over
5, 1, 2.
512. Okay, then times half to the power 1 will also give us what? Half. Okay, so in effect, we are going to get 5 over 512.
Yes, please.
Okay, so 5 over 512. We are done with the A. Is my point well made, my professors?
Yes, please.
Yes, sir.
Okay, so the first one we are doing it together. Okay, maybe going forward, where I know that you've been given all the tools. Okay, I will call you one after the other to guide me to present. So be on the alert. Okay, so now what do we have? We move on to B. B, what are we looking for? Okay, therefore P, okay, capital P, no tails. Okay, so this will be equal to here, unfortunately, okay, the outcome in this probability, okay, notation that we have here is not the success, it's the failure. So we cannot quote the x, okay, px is equal to straight away. We have to change it to our success first. So p no tail is the same as what? P what? In terms of our success.
10 volts.
Okay, 10 hertz. Okay, so which in effect, now that it's in terms of our success, we can now quote it in terms of x. So it will be x is equal to what? 10. All correct, my professors.
Yes, sir.
Okay, so now we are in a very comfortable lead, pole position. Okay, so now what do we do? Quote the formula. So the formula is going to give us, we are using the formula. So it will be 10, okay,
Combination 10.
combination 10, then 1 over 2 to the power 10, okay, then 1 over 2 to the power 0, okay, which in effect will give us 10 combination 10 is 1, okay,
Yes.
then times, okay, 1 over, okay, 2 to the power
1,
10 is giving us,
1024.
okay, 1024, okay, then times 1. Okay, which in effect will give us what? 1 over 1024. Point well made, my professors.
Yes, please.
Okay, so now the last but not the least. Okay, so that will be the C. Okay, C, what are we looking at? Therefore, okay, we are looking at P more than 8 hertz. So more than 8 hertz. Okay, so we know that this will be equal to P more than 8 hertz is the same as what? Is it greater than or equal to 8 or strictly greater than 8?
Really greater than 8.
Strictly greater than 8. So which you know it is an inequality statement. So this will give us x is what? Strictly greater than what? 8. Okay, and someone can also write greater than or equal to 9 is the same thing. Do you agree? Okay, so now if you look at this, let's look at the original direction. The original direction will do 9, then 10. Is that not it?
That's good.
Okay, so now we will apply the function twice. Okay, and here we could use x, okay, directly because you know this is in terms of what? Our success. Okay, so 9 and 10, 2. Now if you want to go the opposite direction, you do 0 up to 8. Okay, and even after doing that, that's not all. You go and subtract from 1. So obviously that would be a big load. Okay, so now we have to move or look at the original direction. So this will give us p x is equal to what? 9. Okay, then plus p x is equal to what? 10. Am I right?
Yes.
Okay, so at this point, what do we do? This will be equal to, are we going to write 10 combination 9? Then half to the power 9. Is that what we are going to write?
No.
Is that what we will write?
No.
Did I hear yes?
No, please.
Okay, so what do we do?
We infer from the
You
previous.
infer. So check, always check whether any of the probabilities that you have there, okay, you've used the function already, you know its value. So we know ps is equal to 9. We know ps is equal to 10. So you just come and substitute their values. So I will do that at the back then. So this one is 5 over 1, 5 over 512, then 1 over 1024. So let's move on to the next page. So that will be equal to, okay, 5 over 512 plus what? 1 over 1024. Okay, so I'm waiting for your answer. Hello, my professors, I'm waiting for your answer.
Mm.
11
11 on 1 0.
104.
11.
Okay. Do you all agree?
Yes, ma'am.
Okay, so that
Yes,
will
sir.
be it for the solution to question 2. Okay, so going forward, I will move, okay, a little faster. So when we get to a point that I know you can continue, just a calculator work, I will leave it, I will write it. Okay. Okay, so now, okay, so let's look at this question. Okay, so maybe we'll think through the question together, then we'll proceed. So I am giving you a minute to read the question and think through. Then we'll all come back and look at the solution together. Okay, so having thought through the question, okay, so let's try and appreciate the question before, because you know you always have to appreciate the question before you start writing. Okay, so now that we appreciate the question, the first thing that you write is solution. Okay, now, okay, with this coin, you can see there's a bias coin. And when the coin is biased, usually we have to give you the probabilities. So we can give you the probability of 1. Okay, maybe one of the outcomes, let me say. Or we can give you the probabilities of what? Both outcomes. Okay, because remember, if you know probability of one, you know probability of the other, basically. Okay, so now let's see. We've been given, so you say probability of obtaining a head is this, and the probability of obtaining a tail is this. If the coin is tossed 6 times, find the probability of obtaining A, 6 heads, exactly 5 heads for B, C, at least 5 heads, D, at least 1 tail. So with this one, okay, we know it's a binomial probability question. So if for nothing at all, we know you have to write a question number after solution. Okay, then we write a probability function, binomial probability function. So capital P, okay, x is equal to small x. Okay, and that will be equal to what? Okay, we get n combination x. Okay, p to the power x. Okay, then q to the power n minus x. Okay, so now we need what? Our n, our p, q, and x, but x will vary. So now in this case, we are going to write but. Let's go. But n is equal to what? Your number of trials, fixed trials. N is equal to what in this question? Please, let's go. N is equal to
6.
6. Very
6.
good. Okay, comma. Then P is equal to what are we taking as our success? Look at the question. Let the question always guide you. Which
Head.
outcomes? Okay, head again. So it will be P, capital P. O. So probability of obtaining a head, okay, will be equal to here we are told is what? 2 on 3. Okay, comma. And probability of obtaining a tail will be your Q. Is that not it?
Yes.
Okay, so your Q, okay, will be equal to what? Your P, I'm writing it, of obtaining a tail. You can choose not to write this. Okay, you know, it implies. And that will be equal to what? 1 over 3. Okay, so now what is left will be our x. Then we are good to go. But we'll pick the s from, okay, the questions. So A, all right, so I will call you one after the other. Therefore, okay, P, okay, what's capital P O? Then we have 6 heads. Probability of obtaining 6 heads. Okay, will be equal to. Okay, so now let me see who will be on my radar. All right, okay, Prof. Alan, let's go. Set the ball rolling.
P into bracket.
Remember, I told you don't say P into brackets. Probability of.
Probability of x is equal to 6.
Okay.
Then 6
Equal to.
combination
Equal to.
equal to 6 combination 6.
Mm-hmm.
Times
Mm-hmm.
2 over 3.
Very good. So it is no more our usual fair coin. 2 on 3. Mm-hmm.
Raised to the power 6
Mm-hmm.
times 1 over 3
Mm-hmm.
raised to the power 0
Okay. Mm-hmm. So let's go. Equal
equal
to
to
any
1.
number combination itself is 1. Mm-hmm.
1
Times 2 to the power 6. So you 2 on 3 all to the power. This here I've told you each of the factors use your calculator, so don't worry. So I'm waiting for your calculator value. This will give us 1.
so 2 over 3 raised to the power 6
Will give us,
is equal to
you don't have a calculator. Oh, we shouldn't waste time on this. I'm waiting. Please, if you know the value, state it and let's go.
This
64.
is 64 on 729.
Okay, so 64 on 729.
I'm coming.
Okay, so this in effect will give us 64 on 729. Is that not it?
So it's not beside me.
Come again. Your calculator is not with you. You are coming to a math class and you left your calculator somewhere. Okay, so in any case, we've been able to state the value. So don't worry. Okay, what is important is this. The rest is calculator way. So I don't expect you to get it wrong. So that's okay. Okay, but come to class with your calculator. This is a math class next time. Okay, so B. Prof. Stephanie, let's go.
Yes, miss. Therefore,
Mm-hmm,
probability
mm-hmm.
of exactly 5 heads.
Okay. Mm-hmm.
equal to
Mm-hmm.
My
probability.
network is bad.
Okay, Alan, Stephanie is on the floor now, so you can mute. Stephanie, let's go.
Let's see. Probability
Mm-hmm.
of x equal to 5.
X is equal to 5. Okay, very good.
This is equal to 6 combination 5.
Mm-hmm.
Open brackets 2 on 3 raised to
Mm-hmm.
the power 5.
Mm-hmm.
Open brackets 1 on 3 raised to the power 1
Okay.
equal to 6.
Mm-hmm.
Open brackets 32 on 243.
Mm-hmm.
Close bracket, open bracket 1 on 3.
Mm-hmm.
Then the final answer is 64 on 243.
243.
It's 243.
Okay, so that will be it for B. All right. Okay, so Prof. Princess, let's go. C.
Therefore, P probability
Mm-hmm.
of, of at least 5 heads.
Mm-hmm.
Uh,
Mm-hmm. Is equal to. Let's go.
P into brackets.
I've told you don't say that.
Yeah.
Probability of. So P.
Probability
Mm-hmm.
X is greater or equal to 5.
Okay. Very good. Mm-hmm. Equal to.
1.
Okay. So will you go the normal direction?
No, please.
Okay. So that's why he started by saying 1 minus.
Probability of X is equal to 6.
S is equal to 6. Very good. Okay. So which will give us 1 minus.
64
Very
over
good. You've
700.
done. Okay, very good. Maturity in your presentation. That's what I want to see. So 64 over 729. I've told you before you infer, make sure whatever you have there is correct. Other than that, we are doomed. So this will be equal to, so the final answer, what's on 729? I'm waiting.
665.
So it will be 729 minus 64. That is what will occupy your numerator. And that will be 665. Am I right?
That's fine.
Or there is something wrong there. Prophet Fee, Akosia.
I don't get why it's 1 minus the probability of getting X is equal to 6 and not probability of getting X equal to 5 plus probability of getting X equal to.
Okay, all right. Okay, so you can do probability of x is equal to 5, plus x is equal to 6. That one, how many times will you apply your function?
Twice.
You are right. This direction is supposed to be the right direction. The other direction that you subtract it from 1 will be from 0 up to what? Up to 4. Okay, so Prof. Princess, you can see. Okay, it means there is a problem here. Okay, it seems I overrated you. All right, so let's go and do the right thing. You get it, professors? You didn't do your check well. Okay, so that's how come we find ourselves in this trouble. Okay, so let's go and clear the whole of this. So this statement here is wrong. We cannot use the opposite direction, okay, that will subtract from 1 because the opposite direction will involve more work. Princess Afa,
Yes, please.
okay, so at that point, okay, I know, okay, our math's gone like that. So this will be equal to P, X is equal to, so I put here, thanks for drawing our attention. X is equal to 5 plus P, okay, X is equal to 6. Okay, which in effect will be equal to P, X is equal to 5. We have done, that is 64, okay, on 243. Okay, plus X is equal to 62 is here. So 64 on 729. So Akosi, I guess you have the answer now. Okay, so give me the final answer. What's on 729?
256
Okay,
on
so
729.
256 on 729. My professors, I hope you are with me now. Okay, so I've given you all the tools. Okay, so please take note. So this shows that at least whatever information that I have equipped you with, okay, you really have it at your fingertips. So, Princess, make sure this never happens. Okay, again. All right. Okay, so that would be. We haven't done the D. Okay, so Akosia. Okay, let's do the D. Okay, so you take care of the D.
Therefore, probability of getting at least one tail
At least one tail.
is equal to
Mm-hmm.
probability of getting at most 5 heads.
Okay, so please, okay, like you realize from the previous one, the assignment. Okay, now I'm going to advise anytime you see at least one, take it to it, use the relation before you change. Don't change directly. It's usually better to use the relation whenever you have at least one. So that will give us 1 minus P. Okay, no tail. Do you agree? Prof. Akosia, do you get it now? Akosia and her network.
Yes, please.
Okay, so now let's proceed. So it's here that we are going to change. We should change this. So this will give us P what? X is equal to how many hertz? Okay, you let me write it in web. As you
60.
mature, you can skip, okay, what I wanted to skip. But I'm writing it just for you to understand and follow. Okay, so this will give us how many tails? So no tails means how many hertz? 6 hertz, am I right?
6. Yes,
Okay, so
yes,
let's go.
please.
So this will give us 1 minus P x is equal to 6. And have we done x is equal to 6? Yes. Okay, so that will give us 1 minus x is equal to 6 will give us, okay, x is equal to give us 64 on 729. Okay, so 64 on 729. Okay, which will be equal to 729 will be your denominator. Your numerator will be 729 minus 64.
65.
Okay, so that one is the one that will give us the 665. Point well made now. Okay, very good. So this will be it for, okay, question number 3. Okay, we are moving gradually. Okay, so let's see. The next question. Question number 4. Again, I'm giving you some few minutes to think through the question. Okay, then, okay, we'll look at how best to carry out our presentation. Okay, so you have a minute to think through the question. Read the question and think through. Okay, so now that we appreciate the question, let's see how best we can deal with it. Okay. So when you read a question, probability that Yaba will be late for school each day is 1 over 10. Find the probability that out of 5 consecutive days, okay, so she will be late on exactly 3 days, on at least 3 days. Okay, so here, if you are supposed to consider your outcomes, okay, what do you what do you think the outcomes will be? Remember, when you are tossing a coin, we know the outcomes will be head or tail. But in this particular event, okay, or in this particular experiment, if I should so put it, okay, what do you think will be the outcomes? What do you think will be the outcomes? When the probability of event, the event is stated, you should know that the event will contain an outcome. Okay, sort of. So if you read the first probability statement, it should give you an outcome. Once you know the outcome, you should know the other outcome that you are supposed to take as, okay, your failure or your success, depending on the nature of the question. Hey, do you want me to help?
Yes.
Okay, so you know, okay, it's either you are late or you are not late. So this will be the two possible outcomes. You get it? Always late. Okay, so the probability that, okay, Yaba will be late. So you are looking at P late. So it means late is what? Your outcome. Or will be late will be your outcome. You get the point?
Yes.
Okay, so some of these things, it will come by experience. As you move on, okay, you will know. Okay, so it means late, okay, and not late, which will be the complement. Okay, I didn't want to use complement because we haven't done commat, but I mean commat probability. But complement, you know that of what do you call it? A set. So you should understand, okay, when I use it here. Okay, so basically this is it. We know this is a probability, binomial probability question again. So what do we do? Because we have a fixed number of trials. Okay, our probability of success remain the same because we said the probability of Yaba being late, okay, is 1 over 10 each day. Okay, so take note of that. All right, so in this case, what do we do? Once we know it's binomial, it satisfies the condition, we write question number 4. Solution is what we write first. Okay, we appreciate the question, so we know that it's binomial probability question. So it will be P x is equal to x. Let's quote the formula together as a class. Hey, let's go.
And
N,
combination
then P to the power,
N
then Q to the power.
N minus X.
Okay, so which we all know, okay, that we will need per the formula here, we will need the values of all the parameters. So, but, okay, our N will be, if you read the question, what do you think will be your N?
5.
5. Okay, so the sample, okay, days will be 5, the number of trials. So 5. Okay, then P, small p will be equal to probability of what? Your success. And which outcome are you taking as your success? Always go for the outcome that you know its probability directly. Okay, so it will be P late. Is that clear? Okay, and that will be equal to what? 1 out of 10. So once you know P, you know Q. So Q, we know will be equal to, I'm writing it 1 minus P, which will be equal to 1 minus, okay, 1 over 10, which will give us 9 over 10. Is that clear? Let me write it maybe for the benefits of those who wouldn't be able to follow by watching. Okay, but as you mature, you can write it straight away. So that will give us 1 minus what? 1 over 10. Okay, which will give us, okay, 9 over 10. Okay, so now we know all the parameters, okay, and we know that X represents the number of successes which we will get from one question to the other. So now let's go to A. Okay, A, we are looking at, therefore, P what? P late on exactly 3 days. Is that not it?
Yes.
Okay, so late on exactly 3 days. Okay, so this will be equal to. So let's see whether what we have here is in terms of our success. Okay, what we have here is in terms of late. Is that not it? Okay, so we know our
Yes.
number of successes. So it means X will be equal to how many? We said exactly 3, so it will be 3. Do you agree?
Yes,
Hello?
great.
Okay, so in effect, this is going to give us, we know our success, number of successes. So we are going to get 5 combination 3, okay, into your P, which is 1 out of 10, okay, into, so to the power 3. Then, oops, my 3 is looking very ugly. Okay, so to the power 3, which is cube. Okay, then into, okay, 9 over 10. Okay, to what power? If you add, you should get a 5, so squared. So we are going to get 5 combination 3 will give us,
10.
come again,
10.
10. Okay, very good. So this will give us 1 over, as for 10 to any power, we can get it. So how many zeros?
3.
Okay, then this will give us, numerator will give us 9 squared, which is 81, over 10 squared, which is what? 100. Is that clear?
Yes.
Okay, so the 0 here will be cancelled by one of the zeros in the denominator. So it means, in effect, we get 81 over 1000. So we left with 4 zeros in the denominator. We are done. So far.
Yes. Yes.
Okay, so on that note, we will do the B. Okay, so let me see, okay, who will be on my radar. Okay, now we are serving. It means another person has joined. Okay, Prof. Muiza, let's go. Okay, let's look at the B. Okay, Prof. Alan.
Yes, 4 zeros. You're missing 3.
Oh, I wrote 3. I said 4, then I wrote 3. Okay, thanks for drawing my attention. Okay, what was I in there? I read 2. Okay, so Prof. Muiza, if you can hear me, let's go. Therefore, we are looking at the B. P late on at least 3 days. Prof. Muiza, can you hear me? Please unmute and respond. If you can hear me, unmute and respond. Okay, all right. So let me check if he is still with us. Okay, I think she's disconnected. Okay, so let's do it together as a class. So that will be equal to probability of. Okay, so what we have there is also in terms of our success late. Okay, so we are going to get x at least means, okay, greater than or equal to. So it will be greater than or equal to 3. Is that clear?
Yes.
Okay, so now let's see which direction will be best. If you want to look at greater than or equal to 3, you do 3, you do 4, and you do 5. Is that clear?
Yes.
So you apply your function how many times? 3 times. Okay, let's look at the other one. The other direction, you have to do 0, 1, and 2. Okay, so that one too, you apply your function how many times?
3.
3 times. So all of them 3, 3. But the difference will come in. With the other direction, when you do the 3, that's not all. You have to subtract it from 1. You get it? But if you go the normal direction, if you do the 3, okay, you don't subtract it from anything. So it means we'll go forward the normal direction. So when the number of times that you apply your function the same, you use which one you subtract from. Okay, 1. Okay, to determine which one will give us less work or more work. So the one that you subtract from 1, when you have equal number of application of or the use of the functions, the one that you subtract from 1 will not be the ideal way. So it means it was the normal direction that okay we have to go for. So in this case, this will be p x is equal to what, 3 plus p, okay, x is equal to 4, then plus p x is equal to 5. You can't go beyond 5. Okay, so here, I think from here we can carry on. Is that not it? You've done 3. So
Yes,
3, don't
please.
waste your time. Come and write this value here. Okay, so it means this will give us 81, okay, over, okay, 1, 0, 4 zeros this time around. I won't miss it. Then plus, we haven't done this. So this one you do 5 combination 4. Okay, then 1 over, okay, 10 to the power what? Okay, 4. Then 1 over, okay, sorry, 9 over 10. Oops. Okay, so 9 over 10, okay, to the power 1. Then plus, let me come down. And that will give us what? Okay, 5 combination 5. Okay, then 1 over 10 to the power 5, then 9 over 10, okay, to the power 0. So I guess the next one we can continue. Safa.
Yes.
Okay, so can we,
Yes.
okay, say that this question is also treated and discharged? You can continue from here, is that not it? The rest will be calculator work. How to deal with these ones will be easy for you. Okay, so on this note, we can go and have our water break. So I'm giving you 5 minutes water break. By 7:10, you should be back. Okay, so you are welcome back from your water break. Okay, so again, a minute. Okay, read the question, think through, and let's see how best we can deal with this question. Okay, this is just a single question with no babies. Okay, so think through just a minute. Let's see how best we can. Okay, maximum 1 minute. We can appreciate the question and look at okay the ideal. Okay, ideal solution. Okay, so now having thought through the question, I think I can ask. Okay, you can see that this question is a little different from what we've done so far. Okay, with this question, you don't directly see the probability of an outcome given. Okay, you don't directly see it, but indirectly there is a probability. Okay, we can see that so far you are asked find the probability or the probability of a fair coin being tossed, Okay, you see probability in your first sentence, but here you don't see a direct probability. Okay, but there is. Okay, so let's see. With this one, to remember, I said any statement that you have the check, which one you are going to take as your success, which outcome will be your failure. So look at the outcomes that you are okay considering. Okay, so in the first statement, in a large sample or sentence, I should say, in a large sample of toys, it is found that 1 over 6 are defective. So what are we looking at? What do you think will be, okay, the outcome, okay, that we must consider as our success, our failure in this situation? Any ideas, my professors? Remember the other one was late, not late. So what are we considering here?
Effective and not
And not
defective.
defective. Please, do you agree?
Yes, please.
Okay, very good. So we
Yes,
have two
please.
outcomes, defective, non-defective, or not defective. So you are supposed to pick one, okay, as your success, either the defective as your success or not defective, okay, as your success. And once the success is fixed, automatically the other one becomes what? your failure. Okay, so take note. All right, so in this case, okay, if you look at this critically, directly, okay, you wouldn't see that what you are giving here is the probability of defective. You know that probability will always be a quantity over another quantity, true or false. So you are picking something
Yes.
out of a total. That's why you have the number of what your event over the number of what your sample space, and your event will always come from your sample space. So something out of something. Okay, so you don't see direct probability here, but indirectly you are giving the probability of what your sample being what defective, or your toy, I should say, being defective. So indirectly we have P defective. Is that clear?
Yes.
P toy is what defective. Okay, so now we know per experience we know that this satisfies the binomial probability distribution. Therefore, we know what to do. So 5. Okay, we quote the function P x is equal to x will be equal to here. Let's go. N combination
Mm.
x. Okay, then p to the power x, small p to the power s, small q to the power n minus what? X. Okay, so we need our p, q, n, and x, which will vary. So, but your small p, oh sorry, small n or n will be equal to. So here, what will be the sample? Remember when I introduced you to the condition, I said n is the number of fixed, okay, trials, or the fixed number of trials, or the sample. You remember I said I put in brackets the sample. You remember I did that. So it will not always be direct that you are dealing with a fixed number of trials. Sometimes you will see that we are looking at sampling. So sample. All right. So here the second one comes in, which is the sample. So how many sample? The sample size?
8.
8. So n is equal to what? 8. Okay. I hope you are following my professors, especially Prof.
Yes.
Muiza. You are having unstable network, I think. All right. So then P, your small p, will be equal to, you are looking at capital P, P of, we need to fix our success. And we said success will be what? Defective. Is that clear?
Yes.
Okay. So that will be equal to, I'm coming down. So that will be equal to, we are told it's 1/6. Okay, comma. Then Q, we know will be equal to 1 minus P. Okay, so that will give us what? 1 minus 1/6, which will give us 5/6. All correct. Is my
Yes.
point well made, my professors?
Yes.
Okay, very good. So I did that mentally. You can also do it mentally. Okay, so now you know your x will vary from one question to the other. So here, what are we looking for? We are looking for, so therefore, okay, P, exactly 2 are not defective. You get it?
Yes.
P, exactly 2, and I will use the number 2. Okay, not defective. Okay, so this will be equal to, can I say that this is the same as P, x is equal to 2? Hello, can I say that?
Yes.
Okay, yes for
No,
Stephanie. So all of you agree is yes.
No, no, no,
no, please.
Stephanie, you submitted your work.
no, 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 no. Please, I want to.
All right, okay, so you know, obviously, this is not defective. You picked your success as defective. So it means you have to move from your failure now to your success. Is it clear? The question was in terms of your failure, not in terms of your success. Unless you pick, so we'll go and pick not defective as our success and see how best we can deal with that one too. Okay, we'll do that one here and see. Okay, I see you understand. You know, maths, you can play with the question once you understand the question. Okay, so now this is what we have. So I know that this will be P exactly, or I can choose not to write exactly and pick the exact number of what? My success. So my success is defective. So if two are two not defective, are not defective, then it means how many will be defective? Remember your number of your sample size. So it means 6 will be defective. Do you agree? You subtract this one from your end. So 6 defective. My professors, I hope you are with me.
Yes, miss. Yeah.
Okay, so now that we have this in terms of our success, we can now write our x. So x will be equal to 6. Okay, so we know this will be equal to 8 combination 6. Okay, into your p is 1 over 6. Okay, to the power 6. Then into your q is what? 5 over 6. Okay, also to the power 8 minus 6, which will give you 2. So square. So this will give us 8 combination 2 is what?
28.
28. It should give you 28. Okay. Then 1 over 6 to the power 6.
1 on 4, 6, 6, 5, 6.
1 on what?
4, 6,
6,
6,
6,
5.
5, 6. Okay, so 1 on 4, 6, 6, 5, 6. Okay, if she's right, I'm also right. Then you should be able to. So this one we know give us 25 over 36.
Yes.
Okay, so now you use your calculator to do everything here. So I'm waiting. Forgive me. I'm waiting. Who is done?
175 on
175. Mm-hmm.
on
On
4, 1. Yes, miss.
on 4.
4, 1,
Mm-hmm.
9, 9, 0, 4.
Okay, so if she's right, I'm also right. Okay, all right. Okay, so thank you. So, like I said, let's look at a situation where you take, okay, your not defective as what? Your success. So, if you take not defective as your success, but I've already advised you, go for the probability. Sometimes when the question is open like that, go for the probability of the outcome in that you know its probability given. Okay, as what your success. Take that one as your success when the question is of this form. However, if you are at liberty to go for any of them as your success, I've told you. So here, assuming, so alternative method. My professors, I hope you are following.
Yes,
So
miss.
you quote the formula, it will be the same formula that you quote. Okay, then you come and write, but your n is equal to what? 8. Okay, your P will be equal to P not defective. So we are picking not defective as our success this time round. Okay, not defective. Okay, we know. So you cannot take this as what? As because the probability here is rather for defective. So that will rather give us 5 on 6. You get it?
Yes, miss.
Okay, then comma. Okay, so comma your Q. Okay, now will be the the defective, which will be 1 minus 5 on 6. So that will be what we have here. In any case, that was given, so directly. Okay, so let's see what will happen. So therefore, P exactly exactly 2 not defective. Okay, will be equal to, because we pick not defective as our success, it means straight away we can use our x. So x will be equal to 2. Do you agree?
Yes, please.
Okay, which will be equal to, hey, let's go. 6 combination, 8 combination 2, am I right?
Yes,
Into your success is now not defective, which is 5 on 6. Okay, to what power? To the squared.
two.
Then into, okay, your q now is 1 on 6. So 1 on 6 to what power? Remember, you add, you have to get 8. So it will be 8 minus 2, which is what? 6. Okay, so now, okay, let's do this and see. 8 combination 2.
20,
You said what?
28.
28. Okay, so that will give us 28. Okay, and obviously you can see 1 over 6 is here. Okay, you know 8 combination 6 is the same as 8 combination 2. Okay, from going, so 1 over 6 to the power 6 is here. Okay, so it means this, whatever we had here, the 5 on 6 squared, this is now going to be our second factor. So that will give us the 25 on 36. And obviously you can see that we'll land at the same answer. Then 1 over 6 to the power 6 will give us the 1 over what? 4, 6, 6. Okay, 5, 6. Which in effect we know will give us the overall result that we had here. 175 over, okay, 4, 1, 9, 904. Okay, so the way you, that's the more reason why, okay, I said in your presentation, don't forget to let us know which outcome you are picking, okay, or you are taking as what your success. Okay, so if you just write P is equal to this, I wouldn't know the one that you are picking as your. So always write P is equal to probability. Then once you write something in bracket, you will know what you give us a rough idea, if not the exact ideas of what you are picking as what your success. Is my point well made?
Yes.
Okay, so that will be it for question 5. Now 2 more questions to go. Okay, question 6. Okay, which is also somehow different. Okay, in an examination, 90% of the candidates passed. Okay, percentage, indirectly, we can look at it as what? As, okay, what do you call it? Probability. So it's 90 out of 100. You get the point? So your sample space was 100 and your number of events, okay, or your number of successes you had was 90. As simple as that. Okay, if 8 candidates are selected at random, so again, we are dealing with selection. So our sample size, we are talking of what? 8, which is the same as our n. Calculate the probability that exactly 5 passed, then at most 3 failed. Okay, so you can see that this one is 1:1. You get the point. One question is in terms of what you will likely take as your success and the other your failure. So obviously you know your outcomes will be pass then fail. Okay, so you need to pick one as your success. Now remember I've told you go for the one that the percentage is directly given. Pick that one as what your success. So here you can see that is the percentage of those candidates who passed. So I will take passed as what my success, and automatically failure becomes my failed. If I'm supposed to put it that way, failure becomes my failure. Okay, all right. So now what do we do? Solution. We appreciate the question. So solution. Okay, question number 6. I know Seto and Muiza, you've not spoken yet. Okay, so you talked today before. Okay, for fairness, you all leave. Okay, or we end the class. So we are going to get solution. That's what we write first. Okay, then question, major question number 6. Okay, now let's see. This time round, the probability is given in terms of percentage. Okay, but you know that every percentage can be expressed as a fraction. So if you want to work with a fraction, work with a fraction. Only that usually I will tell you, okay, or we will advise that if the probability is given in terms of decimal, when you also calculate your probability, leave it in terms of decimal. So equally, I can say if your probability is given in terms of percentage, leave your answer in terms of percentage. But I will usually tell you that is a decimal, that fraction, fraction, decimal, decimal. But percentage, if possible, leave it in terms of fraction. Okay, if you can take, if you want to take it to percentage, to take it to percentage is allowed. Is my point well made, or I should come again?
Please come again.
Okay, so I said, if you consider so far, okay, when you realize that your probabilities, okay, the probability of your failure, your success, given in terms of a fraction, you end up getting any probability that you are asked to find also in terms of fraction. Then I said, if your probability is given in terms of decimal, okay, work with decimal. So it means any probability that you are asked to find, okay, your answer must also be left in terms of decimal. And I said, at the normal circumstance, if your probability is also stated in terms of percentages, any probability that you are asked to find must also be left in terms of percentages. But I said, with the percentages, we can relax. We can equally leave it in terms of what? Fraction, rather than decimal. Points well
Yes,
made.
please.
Now,
Yes, please.
okay, great. So on that note, you know binomial probability. So we quote the formula. So P x is equal to x. Okay, will be equal to n combination x, p to the power x. Okay, then q to the power n minus x. Okay, so now at this point, but so now let's go. Let's look at the values of the parameters from this question. So but n is equal to, what is the value of n?
8.
8. Okay, P will be equal to P. What are we taking as our success? Passed, is that not it?
Pass. Yes,
Okay,
please.
so pass, okay, will be equal to, so let me use past. Okay, so that will be equal to, that is, we are told it's 90 over 100, is that not it?
Yes, please.
Okay, so leave it in terms of its smallest fraction. That will give us 9 on 10. Is that clear?
Yes, please.
Okay, then on that note, it means our Q, which will be P failed. Okay, will be 1 minus P, sorry. Okay, so that would be 1 minus 9 on 10, and that will give us 1 on 10. Am I right? So
Yes.
now you come to A. You don't leave a space. Okay, so A, we are looking at P, exactly, probability that exactly 5 passed, exactly 5 passed. Okay, so the probability that you are looking for, is it in terms of your success or your failure?
In terms of your success.
Okay, so once it's in terms of your success, it means you can write it in terms of x. So x will be equal to, so 5. Okay, so now this will be equal to, okay, we'll get 8 combination 5. Okay, then your success, probability of your success is what? 9 out of 10. Okay, then to the power 5, oops, to the power 5, then into 1 out of 10 to what power? Okay, to be 8 minus 5, and that will give us 3. All correct.
Yes, please.
Okay, so on that note, okay, we are going to get, let's go. 8 combination 5 should give us
56.
56. Okay, should give us 56. Okay, then this will give us into 9 over 10. I'm waiting, 9 over 10 to the
Five
power.
nine
It will give you
five nine
0.
049
59
049 over
59049 over
over 100,000
Okay, 5 zeros. Then this one, we can get it easily. So, okay, 3 zeros. Am I right? Okay, so your calculator straight away for all that. I'm waiting. My professors, I hope you are following.
Yes.
Great, all right. So the next one, I will call one of you to help us do
Three,
it.
three,
3, 3. So a fraction with the numerator.
three, three, one
Mm-hmm. Mm-hmm.
on 10,000.
On 10,000.
Yes, miss.
Okay. Please, do you all agree? Hello, do you all agree?
Yes.
Okay, so I'll take your silence to mean yes. Okay, so now let's go and look at that of the B. Okay, so Prof. Seto, let's go.
Therefore,
Mm-hmm.
um, probability of at
Mm-hmm.
most three failed,
At most, 3 failed.
three failed.
Mm-hmm.
P
No, just I write P. No, what before the P? Equal to
probability of
mm-hmm.
5 pass,
So I will just write 5
at,
passed.
at least 5 pass.
Very good. You know, it's in terms of your failure. So when you are changing, the at most becomes at least. Okay, then subtract this one from the total of 8. So 5 then passed. Okay, we are there. Okay, so now that is in terms of your success. Let's go.
P
Hmm.
probability of x is equal to 6,
No, write the inequality first.
and P probability of
At least 5 means
at least 5 means x is
you are flipping. Who to apo? Seto who to
no,
apo macho?
no,
Oh, but you know, at least 5 means 5 or more. So greater than or equal to 5.
it's greater than or equal to
Oh,
5.
okay. So which will be equal to? So now this will determine the direction. So if you go the normal direction, you do 5, 6, 7, and 8. Is that not it?
Yes.
If you go the other direction, you do 0, 1, 2, 3, 4. So 5, 6, 7, 8. All of them 4, 4. Or the other one will be 5.
The other one is 5.
Okay, so which direction do we go for? Normal direction or opposite direction?
Normal direction.
Normal. So let's go. So that will give us P.
X is equal to 6.
No, equal to 5. 5 is part.
Oh, X equal to 5.
Don't throw my marks away, oh, please. Okay, plus.
P X equal to 6.
Mm-hmm,
P X equal to 7.
mm-hmm.
And P X equal to 8.
Okay, so you know what to do here. You've done, okay, that's of the 5. So you are now going to do 6, 7, and 8, and you add it to the result. So I guess from here, you should be able to continue. Is my point well made, my professors?
Yes.
Okay, so now to our last, okay, question. Okay, so that one too, I will guide you. Okay, so this one, you can't see any direct figure, whether in terms of a fraction or in terms of what percentage, as what, as your probability. Okay, so but study the question and equally you can easily identify the number that we are talking of as what our probability. But before you deal with what your probability, we need to know the probability of your success, probability of your failure. So we need to know the success and the failure before we can find the proper probabilities. Okay, so let's see. If you read the question, for every 10 persons in a city, one is left-handed. Okay, so let's see. The question will guide you. So it means I'm dealing with what? An outcome being left-handed. Okay, and the other outcome automatically will be not left-handed. Is that clear?
Yes.
Okay, so remember, let's see. Okay, so it's a binomial probability. 6 persons are selected, so we know our sample size, which is our n. Okay, so on this note, we are good to go. So 7. Okay, quote the probability distribution function. So x is equal to x. Okay, is equal to n combination x, p to the power x, okay, q to the power n minus x. Okay, then but n is equal to, we know here is 6. Do you agree? Our sample size. Okay, p. We are taking p as what? Probability capital P left-handed. Is that okay?
Yes, please.
Okay, so left-handed. Remember it said let the one that the probability given, okay, be. Okay, so, and that will be equal to. So we said, how do we get the probability here? The probability value. How do we get the probability? Do you see any figure here? Okay, Prof. Akosia.
If for the left-handed in the question, it says it's like 1 in 10 persons, so you have 1/10.
1 over 10, so
So
1 out of 10. So even the previous question that we have here, okay, which is the 9, okay, over 10 that we have here, okay, I can equally put it, instead of saying the percentage, I can equally put it in that same form, this form that we have here. So I could have said, okay, that out of every 10, okay, candidates, 9 was passed. So it will mean the probability of those who pass will be what? 9 out of 10. Okay, so questions in the answer, we just play with the words, just to play on your intelligence. That's all. So these are carefully selected questions to hammer or let you know exactly how you could be tricked and how best you can find your ways out. Is that clear?
Yes.
So don't expect always to see the values, okay, or probability stated there. We started from where you are dealing with fair and the probability, okay, you know. Okay, then we came to unfair, a bias point, okay, probability, okay, which should be given. If it's a bias point, we have to give you the probability. That one, no two ways about that. Either we give you the probability of your success and ignore the failure, or the probability of both the success and the failure. Okay, so take note of that. Or we can put the probability in terms of what? A statement. And you get just as you can see over here. Okay, so now we know that will be 1 out of what? Out of 10. Okay, so on that note, our Q will be 1 minus P, which is 1 minus 1 out of 10. And that will give us 9 out of 10. Is that clear? Hello, my professors, are you following?
Yes.
Okay, so on that note, what do we get? We are going to get I. Let's start with the I. Okay, I, we are looking at, therefore, P, okay, exactly 3. So you can see that, please don't write exactly, you can see that there is a follow-up here. So don't write exactly 3. Exactly 3 what? Exactly 3 are left-handed. That's the probability that we are asked to find. Exactly 3, sorry, more than 3 are left-handed. Then at least 2 are left-handed. Okay, so all that we have here, all the 3 questions that we have here, they are all in what? In your success, directly in your success. So you won't do any change or changes anywhere. So now this will give us for P exactly 3 are left-handed. That's the probability that you are asked to find. So that will be equal to P, okay, because this is already in terms of our success, because success left-handed. So that will give us 3, okay, so X is equal to what? 3, okay, and we can proceed from here. Okay, so that will give us what? 6, okay, combination 3. I'll write only this one, I won't continue, into 1 over, okay, so our P is 1 over 10, okay, to the power 3, so a cube, then into our K, which is 9 over 10, to what power? To the power 6 minus 3, and that will also give us 3. So from here, you can continue. Is that not it? Okay, so Prof. Muiza, okay, crown the day for us, or the evening for us. So therefore, okay, there is no bracket here. Let me clear it. I like numbering my question the way the questions came in terms of its numbers. Okay, so therefore, P, if for nothing apart for what we are asked to find, we can write it more than half. More than half what are left-handed. Okay, will be equal to. Prof. Muiza, are you there? Can you hear me? Please unmute and respond. Hey, anytime I mention your name, your network will go. Prof. Muiza, if I don't mention your name, you are here with me. Immediately I mention your name, then you will vanish. You are hiding behind your network problems. I've seen your plans all. All right. Okay. So this is what we have. Let's continue as a class. So more than half. Okay, what will be the half? We are talking about 6. Okay, so more than half will be what? Is it greater than or equal to 3 or greater than 3? Half will be 3. So more than half will be what? Okay, greater than 3. So X is greater than 3. Is that clear?
Yes.
Okay, so you know greater than 3 will be equal. So let's see whether which direction will be best. If you are looking at greater than 3, it will be 4. It's not greater than or equal to, please take note. It's greater than, it's really greater than 3, more than 3. We didn't say at least 3. Okay, so 3 will not be passed. So you start with 4, 5, and 6. You do it 3 times. If you go the opposite, you do 0, you do 1, you do 2, and you do 3, 4 times. So the original direction will be best. So it will be P, X is equal to 4, okay, plus P, X is equal to 5, then plus P, X is equal to 6. Is my point well made?
Yes.
Okay, and you should know how to proceed, okay, from here. Okay, you've done one of them. No, you did X equal to 3, haven't done so. Okay, this will be, you do it for all, each of the probabilities that you have there. And at least 2, so let's do the last one, I. Okay, so we are looking at therefore P, at least, capital P. Okay, at least. Okay, 2 are left-handed. Okay, so let me see. Seems someone has sent a message. Hey, as for this one there, well, if I don't ask you question, Muiza, this one there, I have my own doubts. Yes, it could be that you have network issues, but it cannot be a sheer coincidence that anytime I call you, your network will drop. Okay. All right. So let's move on. Please don't be afraid to answer questions. If you get it wrong, you are family. If you get it wrong, you will be corrected. That's why you are here. If you are all knowing, okay, if you know everything, I don't know why you should be here. It's because you know you have issues, you don't know everything. That's why you are here. You lack something. Okay, so say it. If you say it, I will know your problem, deal with it, then we move on. All right. Okay, so don't be afraid to answer questions, please. I beg. All right. Okay, so okay, anyway. All right. So let's move on. So at least two. Yeah, so let's handle. So the question is in terms of our success. So it means we can form okay our equation or inequality directly. But you can see that whenever you see at least, it is an inequality. So we are going to get okay x must be what? At least.
Greater than or equal
Okay,
to.
so this time around they should be equal to greater than or equal to 2. So let's see which direction will be best. Greater than or equal to 2, you do 2, you do 3, you do 4, you do 5, you do 6. So 5 times, you apply a probability function 5 times. Let's look at the other direction. You do 0, then you do 1. Is that not it? So that one you do only 2. So it means that direction will be better. So those of you who are hardworking and not smart, you can go the original direction. But those of us who are hardworking and at the same time, okay, and also was smart, will go the other direction. So you know that this will be equal to 1 minus p, x is equal to 0. Okay, then minus p, x is equal to 1. All correct. Hey, 1, then I wrote 0. Okay, all right. So this I need to. So this will be it for today's okay meeting. All right. So that will be it. This one will be given to you as your assignment. Okay. So I will leave this one with you as your assignment. I'll put it on the platform anyway. Okay, all right. So on this note, okay, this becomes the end, okay, of today's lesson. Okay, any questions before I finally bring the curtains down? Okay, so I am ending
And
the lesson. Yes, Prof. Stephanie.
this is it the end of the topic to or
No,
one
it's not
more
the end of
stuff?
the topic, please. It's
Mm.
not the end. Okay, it's the end of today's lesson. That's what I said. Okay, so on this note, thank you very much. Okay, the for your time. Okay, and the opportunity to teach you. Okay, and availing yourself to be taught. Okay, God bless us all.